Right. So hey guys, welcome back to our YouTube channel Code and NGs, and today we're going to discuss the video solution of problem number C, jury meeting, which was asked in a recent contest, Education Law 113. Right. So this is a problem which requires you to have a prerequisite knowledge of combinatorics. And before we go down to the mathematics of this problem, we should first understand like what uh, can we basically observe in a particular permutation for it to be a nice one, right? So first I'll advise you guys to read the problem, and now let us just directly go to how we should solve the problem, right? Let us take a base case, like a base example where we have an array which looks like this, right? Great. So what is the first observation that you'll have? The first observation would be that our answer revolves around how do we place the largest number in the array to make sure it is a nice permutation, right? So if we have 4 over here, how do I make sure that I place numbers to the left, numbers to the right to make it a nice permutation, right? So before this, I'll ask you to let us just simply go through a base case which is there in this problem, which is pretty simple and pretty adjacent if you see. If we have if the frequency of the largest number, which is 4 in this case, is greater than 1, then all possible permutations, n factorial permutations, will be the answer. Why? Because if we have the frequency to be greater than 1 of the largest value, then you'll have at least two fours or more than two fours, right? In this case, in the last traversal, both of them will simultaneously drop down to 0. So it will never basically happen that either of these elements will have its task being simultaneously done one after another, because they will get nullified to 0 at the same time. So all the leftover elements may get 0 in earlier like iterations. These two numbers will always drop down to 0 at the same time. So if you have the frequency of the largest number to be greater than 1, the answer will always be n factorial, right? Okay, so this is a basic case. I hope you'll all be able to understand it. Now let us go back to the case which is basically the major crux of this problem, that only one 4 is present, right? Only one largest element is there. And how do we go about solving this problem? So I'll ask you first that let us place this 4 over here and correct. Can I say this that I actually require a largest minus 1 value to the right to make it a nice permutation always? Right. So what I mean to say is that if I have 4, I need a 3 in either of these two values or both of them to ensure it is a nice permutation. Why? Because if you consider this original case where all the 3's are present to the left, all the values largest minus 1 are present to the left, in this case, the third transaction, after the third transaction, the third iteration, you realize 4 is the last number. 4 is the last number in the iteration to be reduced, and the iteration will be this, with 4 being the last number reduced. When you'll come back for the last iteration, again you'll go back to this one and reduce it to 0. So the third iteration ended with this one being reduced, and the fourth iteration only had this one to be reduced. So if whenever we want a nice permutation, we need to make sure that largest minus 1 value is present on the right, right? So that after the second last iteration, basically this number, the number to the right, will be the last number executed, so that in the last iteration when this 4 will be reduced to 0, it will not be a back-to-back transaction applied on this 4, because this 3 was the last transaction where took place in the previous iteration, right? So what I mean to say is that for you to formulate an answer, you basically just simply lead a largest minus 1 value to the right to ensure it is a nice permutation. Great. Okay. So pretty simple. How do we go about mathematically solving this problem, right? So let us try to understand in this case, and let us keep a few variables, right, with us. Let us keep uh, like count to be the largest minus 1 counter, which will be 3 in this case, because 3 is present 3 times, and other numbers other than these 3 and 4, which is 1 and 2, right? 1 and 2. Great. So these are the other numbers. Now let us try to build the answer. My recommendation would be let us build the answer to be the total number of permutations possible minus not nice permutations, right? It will be easier to calculate in this way. And how do we calculate the not nice permutations? Well, we need to take care of all those permutations where all the largest minus 1 values are present to the left of the largest value, right? Okay, so the counter is 3, other numbers are 2. If I have 4 over here, either I can place 1 and 2 on the right, or 4 will be the last number and all the 3's have to come to the left, right? So can I say that if out of these other numbers, like let us iterate like from 0, let okay, let me clear this area first and then make you understand what I mean to say. Mathematically, if I say, if I iterate over a variable I, right, where I ranges from 0 to other, right, my answer, like my not nice permutations, right, not nice permutations, the not nice permutations will basically be an addition of count plus I factorial, which this is basically the number which will be present on the left, into other ci, right? I'm selecting the numbers out of others that will be present on the left into the numbers which are now present on the right will be other minus 1, other minus I factorial, right? Let me explain what I've done, right? So I say if the largest number is 4, which is present over here, these are the left numbers, these are the right number. So the left possible numbers can be, if out of the other numbers which are 1 comma 2 in this case, which are not largest or largest minus 1, I can either place like iterating from 0 to the total number of other numbers, I can place I numbers on the left, right, which will make it count plus I, these 3 plus I total factorial numbers, which will deal with a combination of numbers on the left, into like the number that I selected out of the others. So this is basically the total case for the left, into the right case, which will be other minus I factorial, right? So I have to iterate from 0 to other and calculate this particular value, right? Great. Okay. So count plus 1 factorial into other ci, other minus 1. Great. Okay. So this becomes count plus 1 factorial into, okay, so let us open the combinations for this, other factorial divided by other minus I factorial into I factorial into other minus I factorial. And this gets nullified over here, and we are basically finally left with an answer to calculate, which will be I is equal to 0. Let me denote other with O, right? A value O, right? And this will be count plus 1 factorial, count plus I factorial, sorry, into a value which is basically uh, other factorial, right, divided by I factorial. Great. Now, again, this is where math will come in. Or so I tell you, other is a fixed number, so we can take it out of the summation. Other factorial, I is equal to 0 to the value other, count plus I factorial divided by I factorial. Great. Now I'll recommend you to take count factorial outside, right? I'll tell you to take count factorial outside. So this will reduce to, sorry, other factorial into count factorial, and the summation will basically open up to be something like 1 plus count plus 1 divided by 1 plus count into count, sorry, plus 2, yeah, plus 1 divided by 2 factorial and so on. Great. And if I can write in other ways, it will be O factorial into count factorial into basically summation of, right, count plus I C I, where I ranges from 0 to O, right? O is the other numbers and count is the frequency of largest minus 1 in the array. Great. Okay, so these are two constant values, you don't need it. Now, if you want to calculate the answer in higher complexity, you can simply do it by calculating this, but we need to reduce it to a constant function. Now, how do we reduce it to a constant function so that we can calculate the answer? Simply in terms of the particular complexity that we have to calculate. Great. Now, if you just see, right, this opens up to be 1 plus, like, let me just simply reduce it to be a kind of a series which is basically n plus r c r, right? And this is quite funny because this is 1 plus n plus 1 c1 plus n plus 2 c2 and so on. I can write this to be like uh, n plus 1 c0 plus n plus 1 c1 plus n plus 2 c2 and so on. And if you know a formula that we do in higher school mathematics, that n plus uh, like 1 cr plus n plus 1 cr plus 1 is equal to n plus 2 c r plus 1, right? This is a formula that we use in combinatorics, and using this formula you can basically find the answer to this whole continuous series, right? This will basically come out to be something like n plus 2 c2, this will n plus 2 c1, this will add to become n plus 3. Okay, let me just try to show you how it will become. So n plus 1 c0 plus n plus 1 c1 plus n plus 2 c2 and so on, right? This will give me n plus 2 c1, which will add up to this to give me n plus 3 c2, which will add up to this give me n plus 4 c3 and so on. So if you see, like, after adding these number of elements, you're getting an answer which is somewhat like this. So can we derive an nth term for this whole series that we have calculated? Well, it's quite simple. If you just see that the answer will come out to be something around about count plus O plus 1 C O minus 1, which is nothing but this is count plus other plus 1 will give me n C other minus 1, or n C n minus count minus 1. And this is the answer to this whole question. So this is how we basically had to calculate the answer. Here it will be O, right? And this is how we had to basically calculate the answer. So the total answer was n factorial minus not nice things, which was O factorial into count factorial into nc n minus count minus 1. O is basically nothing but n minus count minus 1. So you can calculate the answer to be basically n factorial minus n minus count minus 1 factorial into count factorial into nc n minus count minus 1, and there we have the answer to the answer to the entire question, right? Great. Let us try to understand in code how we had to deal with this question. Great. So simply we just had to take an array. We took the input. Input is a predefined function that I have in my template. Putting an array. We have used long over here just because you're taking a mod and you're multiplying to numbers which can go up to 10 to power 9, right? So it is quite safer to take long despite taking mock, because sometimes it can lead up to the number going beyond the range, right? Great. So we have kept a map to keep a check of total answer and maximum value. This is the first base condition, that if the frequency of the maximum value is greater than 1, simply answer is factorial of n and we'll print it out. And if it is not so, we have to keep a count of all the maximum minus 1 values in the array. And here's the subtraction is basically the not nice permutations that we have. So we calculated is by simply first multiplying this value that we discussed over here, and minus 1 factorial into count factorial. And then we multiplied this value with this combinatrix formula that we just discussed over here, right? And simply we have an answer where we reduce total number of permutations minus this plus mod to make sure that we were answering positive value, and then we just simply go about printing the answer. I know this question can be a little bit tough on math, but it is important to practice such questions to be able to reach up to the solution, right? So if any one of the viewers has a different solution, we are free to basically share it in the community section or maybe in the comment section, and we'll surely discuss about how it can be solved easier than this as well, right? So meet you on the next tutorial. Till then, bye bye, see ya, and have a very nice coding spree.